In this video, we're going to prove the formula for the distance from a point to a plane. The distance from the point P naught, x naught, y naught, z naught to the plane with equation ax plus by plus cz plus d equals 0 is given by the formula shown. Absolute value of ax naught plus by naught plus cz naught plus d all over the square root of a squared plus b squared plus c squared. Now, how are we going to prove that? Well, let's imagine we have the plane ax plus by plus cz plus d equals 0 shown in the diagram. And let's imagine that the point P1 is known to be on the plane. P1 has the coordinates x1, y1, z1. Now, P naught is not on the plane. That's the point given in the question. And it's a point that we want to find its distance to the plane. Well, its distance to the plane is going to be equal to whatever the length of this line segment is. Let's call that line segment just for a second d. We're looking for the magnitude of d, the length of that line segment. Now notice that the plane has a normal of ABC and that this distance d is in the same direction as the normal itself. Okay? And so that'll be kind of significant. Now look at the triangle formed by P naught and R, which is on the plane and perpendicularly from P naught, and P1. Using SOHCAHTOA, we can say that the cosine of this angle right here is equal to the adjacent, which is this segment right here, the magnitude of P naught R. There should be a little P naught there, over the magnitude of the hypotenuse, which is the magnitude of P naught P1. And then just multiplying both sides by the magnitude of P naught P1, we get that the magnitude of P naught R equals the magnitude of P naught P1 times the cos of theta. Okay? Now, we're going to use the dot product next. We know that the normal vector dotted with P naught P1 is going to equal the magnitude of the normal times the magnitude of P naught P1 times the cosine of theta. So what we can do is simply, instead of saying magnitude of P naught P1 cos theta right here, we can just replace that with this PR. And that's what we do in this next question. Okay, we're just literally replacing this magnitude of P naught P1 cos theta with magnitude of P naught R. And then we're going to divide both sides by the magnitude of n, and we're going to get this equation here. Now keep in mind what the magnitude of PR actually is. And again, there could be a P naught there. Keep in mind what the magnitude of P naught R actually is. It's the distance that we're looking for. So what that means is the distance that we're looking for is actually equal to the normal vector dotted with the vector P naught P1. P naught is this point, and P1 is another point known to be on the plane, over the magnitude of the normal vector. We know that the normal vector is ABC, and since we know the coordinates of point P naught and we know the coordinates of point P1, we therefore know the coordinates of the vector P naught P1. And so what we can do is we can say that the normal vector dotted with P naught P1 is going to equal the, divided by the magnitude of the normal vector is going to equal the distance that we're actually looking for. So that's the formula that we have. We're going to use the component method of the dot product, and we're going to say A times x1 minus x naught plus b times y1 minus y naught plus c times z1 minus z naught over the square root of a squared plus b squared plus c squared is going to equal the distance that we're actually looking for. Okay? Now, when we multiply a by x1 minus x naught, obviously we can distribute the a and make it ax1 minus ax naught. And similarly with b here and with c here. And so when we do that, we actually get this expression written here. And what we're going to do next is we're just going to rearrange a little bit. Let's keep it as negative ax naught minus by naught minus cz naught, which is right here. And then we'll add ax1 plus by1 plus cz1, which we do here. Okay? Now, we know the point x1, y1, z1 is actually on that plane. And what that means for the point x1, y1, z1 to be on the plane in question, what it means is that ax1 plus by1 plus cz1 plus d equals 0. Well, throwing that d on the other side, it means ax1 plus by1 plus cz1 equals negative d. Okay? So instead of adding this quantity at the end, we can instead just subtract d on the end. Now, instead of having negative ax naught minus by naught minus cz naught minus d, why don't we just factor out negative 1 and call it ax naught plus by naught plus cz naught plus d in a bracket? Okay, so we do that. Underneath, again, we still have the magnitude of n, which is square root of a squared plus b squared plus c squared. So we have that formula written. Now, remember, distance has to be non-negative. So the denominator shown there is always going to be positive because we don't have a non-existent plane. So therefore, a, b, and c are actually not 0. And we're doing the square root of the sum of squares. So it's going to be a positive number. So we know this denominator will be positive. And let's just put an absolute value around the numerator. But since we're putting the absolute value around negative 1 times a quantity, instead we can just put the absolute value around the quantity that's in the bracket. So what we have is absolute value of ax naught plus by naught plus cz naught plus d over the square root of a squared plus b squared plus c squared. And that is the formula that we were seeking to prove. And all these other questions, we're going to go through them in a later slide or in a later video.